All right, let's do another example with the washer method. First of all, so right here, that's a washer. Like tightens up a screw. I don't know. I'm not big on tools. I should be. It's a useful skill. But anyway, the point is that's a washer. So let's do this one. So if you revolve the area in Q1 formed by y equals cosine of x and y equals sine x about the x-axis. As always with these problems, we'll start with a picture. There's our axes. Cosine, or sine, let's do sine first. Sine, I'll start here at 0, 0, and curve up. And actually, it's not going to curve like that. What am I doing? It's going to curve like this. And then cosine will start at 1 and curve down, something like that, and they'll meet eventually. Let's see where they're meeting. You might already know, but cosine of x equals sine of x, and this is only true when x equals pi over 4. So then right here, that will be pi over 4. Next, I'm going to reflect our shape. I'll just use the same colors this time. So there's that piece, and here's the other piece. So now if we make it three-dimensional, looks something like that. Maybe at the bottom, it'll look something like that. For this example, I'm going to try making 2 separate washers and see if that's more helpful than just making one and looking at the 2 radiuses, radii. So here's our larger outside washer. And there's our radius. And then our inside washer, this part we'll subtract out, this is the hole, will look like that. Now if we set up our integral, we have pi times the integral. It's again split up. We have pi r squared, that's the outside, minus the inside, pi r squared. And so when we integrate, we put the pi on the outside and just make this r squared minus r squared. So then if we look, our lines here are horizontal, the lines we made on our little disc. So it's dx. So our limits will be 0 to pi over 4. Now our uppercase r is our bigger washer. So our radius looks like it goes out to the green function, which was cosine. Our smaller disk or washer, I guess the washer is really the whole piece, so larger disk, smaller disk. Our radius goes out to the coral curve, which is sine of x. So we end up with pi times the integral from 0 to pi over 4 of cosine of x squared minus sine of x squared dx. And from here, you can just use your calculator. And you will end up with a volume of 0.5 pi, or pi over